Chapter 12 is an introduction to statistics. The very first section of Chapter 12 focuses on sampling techniques, frequency distributions, and other graphs. To begin, a random sample is a sample obtained in such a way that every person in the population has an equal chance of being selected for the sample. Also, to truly be random, when you're picking people for this sample for whatever study you are conducting, the best way to get a random sample, a true random sample, would be have something like a computer program that assigns numbers to every person in the population, and almost like a sort of lottery, the computer program generates the numbers for who you should interview or survey as part of your sample. So something that's not biased, in other words, like a computer program would be the best way to select your random sample. So you want to make sure that there's no bias, and that most importantly, to eliminate bias and to make sure you have a fair sample that is going to be more likely to be more accurate, you want to make sure that every single person has an equal chance in that population of being selected for that sample. So these types of questions, these sampling technique questions in the My Math Lab, are going to be multiple choice. And as we're trying to figure out what is the best option, we want to keep in mind, does everybody in the population have the same exact chance of being selected? If not, then that is not the correct answer. So if they only go to one location to interview people, that's not the correct answer, because not every single person has the same exact chance of being selected. So to see an example of this, let's look at example 1. It says the government of a large city needs to determine whether the city's residents will support the construction of a new jail. The government decides to conduct a survey of a sample of the city's residents. Which one of the following procedures would be most appropriate for obtaining a sample of the city's residents? So before we look at the options, let's keep in mind the population we're studying. So in this question, the population would be city's residents, since obviously it's impossible to ask every single person who lives in the city their opinion, if they're for or against using taxpayer money to build this new jail. We need to just get a sample, an accurate sample of the city's residents. So looking at option A, it says survey a random sample of the employees and inmates at the old jail. Well, if you're only going to one location like the jail, that option is already out because not every single person that lives in the city has the same chance of being selected. Option A is also out because if you only interview people that work for or live in the jail, they're going to be biased. Most of those people are going to say yes, they support constructing a nice, new, pretty jail. So A is out. Looking at B, survey every fifth person who walks into City Hall on a given day. Again, you're only going to one location, one building, City Hall. Not every single person that lives in the city has the same chance of being selected if you're only going to one location, so B is out as well. Option C, survey a random sample of persons within each geographic region of the city. This sounds like it's probably going to be the right answer. We're doing a random sample, so we're just randomly picking people that live in every single part, every region of the city. So that seems like every person that lives in the city has the same chance of being selected for this sample. So far, C is the best answer, but let's just check D just to make sure. D is survey the first 200 people listed in the city's telephone directory. Well, not everybody in the city is listed in the telephone directory. So just like with A and B, D is out because not everybody in the city has an equal chance of being selected. So the best answer here and the correct answer is going to be C. Let's try one more of these. Example 2. The City Council of Orlando, Florida needs to know whether its residents will support the building of 3 new schools. The council decides to conduct a survey of a sample of the city's residents. Which procedure would be most appropriate for obtaining a sample of the city's residents? So again, it's impossible to ask every single person who lives in the city if they're for or against using money, taxpayer money most likely, to build these 3 new schools. So that's why we were forced to pick a sample. And as we're going through the options here, we want to make sure that everybody that lives in the city has an equal chance, the same chance at being selected. So starting with option A, survey a random sample of teachers who live in the city. You got to be careful here, because if I'm only asking teachers, there's going to be a bias. Most likely they're going to say yes, they do want to build 3 new schools. So you don't want to just ask one profession or one type of people. Not every person in the city has the same chance of being selected, and your sample is going to be way too biased. So A is out. Looking at option B, survey 100 individuals who are randomly selected from a list of all people living in the state of Florida. Be so careful here. So we want to make sure that our sample matches the population that we're studying. If the population we're studying are the city's residents, the city of Orlando, we don't care about the rest of Florida. Why do I care about the opinion of Tallahassee of how Orlando should use their money to build these schools or not? So you want to make sure that sample matches the population, and my math lab will try to trick you up like this a few times as well. So you really got to read these questions carefully. So I don't care about the entire state of Florida. I want to focus on just the city of Orlando. So B is out because it doesn't match, the sample does not match the population that we're studying, the city's residents. Looking at C, survey a random sample of persons within each neighborhood of Orlando. That seems to be the best option so far. You're going just randomly picking out people from every single neighborhood, every single region of the city of Orlando. So the sample matches the population. You're not picking a certain type of people like teachers out. You're not going to just one location. So everybody in Orlando has an equal chance of being selected. So it looks like C is going to be the right answer, but let's check D just to be safe. So D is survey every 10th person who enters the Florida Department of Education building on a randomly selected day. So D is not the right answer because we don't want to ever go to just one location like this, because not everybody has the same chance of being selected in the city of Orlando if you're only going to one building. So D is out as well. So yet again, coincidentally, it happened to be C. It won't always be C on the homework, but for these first 2 examples on this slide, it happened to be C. So C, final answer. For frequency distributions, which really, as we're going to see here in a minute, are just simply tables, a type of table with 2 columns. So for those tables, there are something called classes. And we're going to see a few examples in a second, but those classes should be the same width, meaning the same number of numbers. The classes should not overlap. Each piece of data should belong to only one class. So I think this is better explained as we see a few examples of these frequency distributions. So jumping right into example 3, it says construct a frequency distribution for the data showing final course grades for students in a pre-calculus course listed alphabetically by student name in a gradebook. So here are all the scores. And they want us to draw the entire frequency distribution. So we said that's 2 columns. I'll draw my little divider here in the middle. On the left side of any frequency distribution is always what we call in statistics the observed values. These observed values are going to be your x-coordinates when we graph these frequency distributions later. And when I look at my data, what do these data points or these data values actually represent? That will help us to be more precise in giving a title to the observed values. So usually it's numbers, but that's not the case here. These letters represent grades in a pre-calculus course. So a good title here would be grades. Now usually in the My Math Lab they'll have the titles for you, but just think observed values, classes, all of that goes on the left side always of any frequency distribution. Now they're not being creative with the name of frequency distribution. The whole point of these tables is to showcase frequency. So the frequency itself will go always on the right side. So that'll be the right column heading. So frequency on the right, and we're always just counting to get the frequency. Since we're going to be counting stuff on the right side, the right side will always begin with the phrase number of. So in a few minutes, when I begin counting all of my observed values, when I begin counting these grades, I'm really counting number of students, because each score is a score that a student earned as a final course grade. So number of students. There are 2 different types of frequency distributions that the My Math Lab is going to give to you. The first type, like this, we can simply have each letter, each observed value has its own row. This is the easier type. The second type we will see on the next slide is something called a grouped frequency distribution, which just requires a little bit more work to it. You'll know if you're dealing with a grouped frequency distribution if there is a hyphen with your observed values. There's not here. So I'm going to go ahead and just set up my grade side, and as I look at these scores, my data, some of the students got an A, some got a B, some students got a C, some got a D, and I'm seeing at least one F. So each observed value, each grade, in this case, gets its own row. Remember, we also call those classes on the left side. And now the easy but tedious part is we need to count them, and the total count is what goes on the right side, the frequency side. What I like to do, because usually the data is all out of order, is I like to make little tally marks. So just to show you what I mean, if I go in order, the first one I see, the first grade I see that is an F. So I'm going to make a tally in the F row. The next grade I see is an A. So there's an A there. Then I see two B's. So I'm going to make two tallies in the B row. I see two C's. I see a B. I see a C. Two A's. Two C's. A D. A C. A B. A D. Two more C's. A B. And a C. And then I just simply count the total number of tallies to fill in the total numbers there on the frequency column. And by the way, when we graph these charts later, the frequency side, the right side, of course, will be the y coordinates. You don't have to use these tallies. I just find it's easier if I slash through each data point just to make sure I don't forget anything. So for A's, we had 3 total tallies there. For B's, we had 5 total tallies. I know it's kind of hard to see with my messy tallies here, but with C's, we actually had 9. D's, we had 2, and F's, we had 1. So all of those grades and number of students, the MyMathLab would take you throughout the frequency distribution, and you would type in all the missing blank spots in the chart. After you do that, it may ask you some questions in the MyMathLab. It might say, for example, how many total students were there? In which case you would just simply add up the frequencies on the right side. So if I do 3 plus 5, that would be 8, plus 9 is 17, plus 2 is 19, plus 1 is 20. So 20 total. So not too hard, just a little bit tedious. You may have to write out all of these data points, these observed values, especially if the MyMathLab gives you a lot of them. That way you can slash through each one just to make sure you don't forget any. But not too bad, just a little tedious and a little time consuming. Let's take a look at a grouped frequency distribution on the next slide. Example 4 says, as of 2017, the following are the ages in chronological order at which U.S. presidents were inaugurated. And there are a ton of them. The source here is Time Almanac. Yet again, they want us to construct a, but now it's grouped frequency distribution for the data. Use 41 to 45 for the first class and use the same width for each subsequent class. So grouped, we do see a hyphen. That's not a minus symbol, that is a hyphen. So all those numbers are going to belong to the same row or the same class as they call them. And it does make it a little bit more time consuming. We just want to be very careful that all of these classes have the same width, meaning the same number of numbers that belongs to each class. So we're still creating a frequency distribution. So that means I'm going to have the same 2 columns as the last example. I'm going to go draw my divider. And remember, the observed values will always go on the left side. I'll put it in parentheses again. To have a more specific title, we look at the data, the values. Values means numbers. So if I look at the data, although it could be letters, as we saw the observed values were letters in the last example, but here we're observing numbers as our data. And I just ask myself, what do those numbers represent? And in this case, all those numbers represent the ages of U.S. presidents. That would be a more specific title for those observed values. Ages of U.S. I'll just put Pres for presidents. And then the right side is always the actual frequency where we count. And it always begins with number of, since we're counting. So in a few minutes, when we count up those ages of U.S. presidents, we're actually counting up the number of presidents. For grouped frequencies, they typically will tell you what to use as the first class or the first set of observed values. And sure enough, they tell us they want us to use 41 through 45. So just be very careful here because we want to make sure we have the same number of numbers, the same width for every class, for all the observed values. So if I'm trying to figure out what the width is, I do not want to do 45 minus 41. That's why I say that's a hyphen, not a minus sign. If I do 45 minus 41, that's going to give me 4. And obviously there is not 4 numbers from 41 to 45. There are obviously 5 numbers. If I were going to count up on my hands, 41, 42, 43, 44, 45, there are 5 numbers as my width number. So to get the actual width number, now these numbers weren't so bad, but let's say that my math lab just gives you really bizarre numbers here. Just think vertically for the width number here. So I asked myself, following this pattern, where would the second row, the second class, begin? So if the first row is from 41 to 45, the second class is going to begin at 46. So to get the width number, you take where the second class begins, which is 46, and what you can subtract is the number right above it, 41. Why? Well, I don't want to do 45 minus 41 because then I will not be including both of those endpoints in my count. So if I go vertical and I do 46 minus the number above it, the initial number 41, then I see my width number is 5. So from 41 to 45, there are 5 total numbers. So again, to figure out the width number, when you see a hyphen, when you have a grouped frequency distribution, you can either count out the numbers on your hands from 41 to 45 to see there are 5 numbers there, or you can just figure out where the second row begins and subtract the original number, the number right above that. So 46 minus the 41 would also give us the width of 5. We're going to use that width number to set up the entire left side of this frequency distribution. So 41 plus the 5 is 46, or even just look at the pattern. So if the first one is 41 to 45, the second row must be 46 to 50. Not sure if you're doing it right? Once you know what the width number is, if you keep adding it as you go down, you can see it'll land you on the next number. So like 41 plus the width of 5, yep, is 46. On the right-hand side, the right endpoints, 45 plus 5, yep, that lands me on 50. So continuing this pattern, 51 is where the next class would begin. If the previous class ended at 50, 51 to 55. The next set would be 56 to 60. Now at this point you're probably asking yourself, when do I stop? Well, if you look up what is the largest data point, the largest number I see is 70. So once 70, the largest data point, is accounted for, then you can stop. So we still have a little ways to go because we're only up to 60 right now. So the next one will be 61 to 65, And then here we go, 66 to 70. Yay! So 70 would be included. That's the largest data point in that bottom row, that bottom class. If you're having trouble figuring out where did I get these numbers from, again, once you know the width number, just keep adding that width number over and over again to go down on the left column. So if I keep adding this 5 on the left endpoints, the numbers to the left of all these hyphens, 41 plus 5, yep, that's 46. 46 plus 5, yep, that's 51. 51 plus 5 is 56. Plus 5 is 61. Plus 5 is 66. You can also add the width number to go down the right sides of these hyphens. So 45 plus 5 is 50. Plus 5 is 55. Plus 5 is 60. Plus 5 is 65. Plus 5 is 70. So once you know this awesome width number, you add it to go down either side of these hyphens. Now the hardest part is over. Now we're just going to count. I'm going to use that tally system that I used in the previous example just to make sure I get all the data points, all these US president ages. There are a lot of them. So here we go, counting them up. The first number I see is 57, which would be here. Obviously 57 is in between 56 and 60. The next number I see is 61, which would be right here from 61 to 65. I see two 57s, so two more here and here, the 56 to 60 row. Let me make these in red. This is actually kind of hard to see in my green. So I currently have 3 tallies in the 56 to 60 row, and I have 1 tally in the 61 to 65 row. There we go. So I've taken care of the first 4 data points. Now I'm on to 58. So 58 again would be the 56 to 60 row. Another 57. So there's my 5th tally in the 56 to 60 row. 61 would be here. 54 would be here, the 51 to 55. 68 would be here. Feel free to pause this video, fill in all the tallies, count them up, make sure we get the same answers. 51 would be here, 51 to 55. 49, so I'm putting the tally where that number lands. So like 49 lands from 46 to 50. 64 would land here between 61 and 65. 50 would land here. 48 here. 65. 52. 56. 46. 54. 49, 50, 47, 2 55s, 54, 42. Yeah, these are really tedious, as you can see. 51, 56, 55, 51, 54, 51, 60, 62, 43, 55, 56, 61, 52, 69, 64, 46, 54, 47, 70. Okay, let's see how many total tallies I have. So I have 2 total tallies in the top row, 9 in the second, 15 in the third row, 9 after that, 7 and 3. Then after you fill in the entire frequency distribution, just like I have on this slide, that my math lab homework could ask you some questions. It might ask you, how many total presidents are there? In which case you'd have to add up your frequencies. So if I do 2 plus 9 plus 15 plus 9 plus 7 plus 3, that will give me 45 total. B, what is the width for each class? The number of numbers. We already did that earlier. The width is 5. To compute the width, no matter what crazy or nice numbers they give you, it's always where the second class begins, that's the second number, which is 46, minus the number above it, which was 41. So second class begins minus where the first class begins will always give you the width number. So those endpoints on either side of the hyphens they call limits. So C says, what is the lower limit for the third class? So first let's figure out where the third class is. So going down the classes, those are the observed values. First class would be 41 to 45. The second class is 46 to 50. So the third class must be the 51 to 55 class. And lower limit just simply means the smaller number. So the smaller number of the third class was 51. So you would just type in 51. And then part D, what is the upper limit? So the bigger number for the fourth class. So the fourth class, going down the classes, 1, 2, 3, 4, was the 56 to 60 row. Upper limit, meaning the bigger number, which is 60. So you would just type in 60. And that's just a little bit of vocab they might throw at you in the My Math Lab homework. After having you create frequency distributions, the My Math Lab will also have you graph frequencies using either a histogram and or a frequency polygon. So in the next example, they've given us the frequency distribution completed already, and they want us to draw both frequency graphs, histogram and frequency polygon. So example 5 says the frequency distribution of the one-way commuting distances for 70 workers is listed in the following table. Construct a histogram and then construct a frequency polygon. So what's nice is that to begin graphing either one, the frequency polygon or the histogram, it starts the same. The labels on the X and Y axes and even the points we initially plot are the same. It's just the way we connect the points together is the only difference. So both graphs will still make the same shape. When you see histogram, just think these are the rectangles or boxes that are joined together. Whereas frequency polygon means you're just going to use these straight line segments instead to connect everything together. So really in real life it's a personal preference since they're both showing the same shape, and usually in real life you would have Excel, a computer program, do this for you for a pretty computer generated graph rather than doing it by hand. These types of questions do tend to be multiple choice, yay, at least in the My Math Lab homework. But knocking out this one longhand, so the left side of the frequency distribution, the distance in miles, those will always be the x coordinates, And the right side, number of workers, the frequency will always be the y coordinates. It goes in alphabetical order, x to y. So let's just go ahead and steal, copy, and paste those labels. So we said the x coordinates, or the x-axis, will be distance in miles. Actually, let me move this over a little bit because we're going to need room for all of our labels. I'll put it way over here. So the distance in miles will be the x-axis. There we go. And then the y-axis, the vertical, will be number of workers. I'll just abbreviate number with hashtag. Now we need some labels. As I look at the y coordinates, I'm seeing numbers anywhere from 5 is the smallest to, it looks like 24 is the largest. So how you want to scale that is up to you. I'm just going to go by 5s in my graph paper, my grid paper here. So this first line will represent 5. Obviously the bottom will be 0 then. So 0, 5, 10, 15, and then 20, and 25. And since the largest number for y coordinates was 24, we can stop right at 25. On the x-axis, the problem is that we have hyphens because this is a grouped frequency distribution. It is not proper notation in statistics to label a tick mark with a hyphen. So, in other words, I cannot label the first tick mark on the x-axis 1-7. I need to figure out one number that would best represent that entire number range. And what they have us do is they have us find the mean average, also known as the midpoint or class mark. Whatever you want to call it, we just simply add those numbers together and divide by 2. So I would take the 1 in parentheses plus the 7, close the parentheses, and divide by 2. 1 plus 7 is obviously 8. 8 divided by 2 gives me 4. So 4 is the midpoint, literally the middle number on a number line from 1 to 7. So again, you just add the endpoints and divide by 2. So I'm going to label the first tick mark on the x-axis as 4. That 4 does represent the entire number range from 1 to 7. Technically, the very, very starting tick mark will be 0 always, going in both directions. All right, let's find the mean average, the midpoint for all the remaining ones. So if I do the 8 to 14 class, so in other words, 8 plus 14, divide by 2. If you're doing this all as one line in a graphing calculator, you do need parentheses around the top always. That's your way of telling the graphing calculator that the 8 plus the 14, that whole part is in the numerator. If you want to play it safe, you could just break it up into 2 steps like I'm doing here. So I would do the 8 plus 14 first for 22. Then divide by 2, step 2 for 11. So 11 will be the label on the next endpoint. And I gotta kind of have to write above a little bit here because in my app, I have a toolbar on the bottom of the screen that's blocking me from writing any lower here. But the next one, 15 to 21, so if I do 15 plus 21, divide by 2, that's 36, divide by 2. which is 18. So 18 would be the next label. So 18 is going to really represent the whole 15 to 21 group. Next up, let's go ahead and create some room here. So we had 4 as the mean average for 1 and 7. Then we had 11. Then we had 18. So now we're going to do the 22 to 28 class. So 22 plus 28 to divide by 2. Always add them up, divide by 2. 22 plus 28 would be 50 to divide by 2, which is of course 25. 25 would be the next label. Next up is the 29 to 35 class. So I do 29 plus the 35 to divide by 2. 29 plus 35 is actually 64 to divide by 2, which is 32. So 32 will be the next x-coordinate label. And finally, 36 plus 42 to divide by 2. 36 plus the 42 would be 78 to divide by 2, which is 39. Again, you only have to do this midpoint, this mean average, if you see hyphens for a grouped frequency distribution. So you have one number representing the entire class. If you don't have hyphens, you don't have to worry about calculating that. You can just leave the number as is. Once you have all the labels, now you can think of this as points, just like in good old algebra. So the first point I would plot, doesn't matter if I want to do a histogram first or a frequency polygon first. You're going to treat these as points to plot. So I see 4, 15. So I'm going to go right 4, up 15 is one way to think of it. Or with this grid paper, where does 4 from the x-axis intersect with 15 on the y-axis? The next point to plot, when I merged these numbers together, was 11, 24. So the 11, and then I got to estimate where about 24 is. It's right below the 25, so around there-ish. Check, check. Okay, the next one up is 18, 13 to plot. So write 18 up 13, which is about here. So where would 18 intersect with 13? Then the next one is 25, 8. Keep in mind this is going to be a multiple choice type question in my math lab, so it'll be a little bit easier. The next one up is 32, 5. So where does 32 on the x-axis intersect with 5 on the y? And then finally 39, 5, when I mush those numbers together to make a point. So we've labeled the x and y axes. We've plotted all the points. So here's the only difference. And I'm going to do the histogram and the frequency polygon on the same exact grid paper here. I'll just use different colored pens. But the way we connect those points together is the only difference. So we said with the histogram, you're going to think rectangles joined together. And you want to start your first rectangle halfway between the tick marks and go straight. And the height of each rectangle is where you made those points. So it's going to be the height of my rectangle. And then you come down halfway between the tick marks. And then you start the next rectangle where the other one left off. They should be touching. There should be no gaps in between your rectangles. And then again, the next rectangle is the height of the next point. I cannot draw to save my life. Normally you would use a ruler to make it straighter, but you get the idea here. And then it's just those Join together rectangles. There we go. Okay, so that is my histogram in red. Now I'm going to use the same points just so you can see the difference and the similarities between the two. But I'm going to use my blue pen for the frequency polygon. I would still start halfway between the tick marks, but now you're just going to go from left to right with straight line segments. Again, pretend I can draw straight. I know I cannot. You can see it's the same shape as the histogram. I'm just not using rectangles, just only using line segments for a frequency polygon, and then you end halfway between the tick marks as well. Maybe I've been to Disney too many times, but this particular frequency polygon always reminds me of the Mount Everest roller coaster at Animal Kingdom. But either way you look at it, same shape, histogram and frequency polygon, you just join together the points a little bit different. Another way we can showcase frequencies is by drawing something called a stem and leaf display, also called a stem and leaf plot. So a stem and leaf display is just another visual tool to organize frequencies when we really just want to show how many of each data point we have. So example 6 says to construct a stem and leaf plot for the following 37 exam scores. So what we would do is we would take a look at how many digits there are for all of our numbers, all of our data. Now these are all 2 digits. The stem is going to always be the first digit out of your data points. So if they're all 2 digits, it's always going to be the first digit will be the stem, and then the leaf will be the remaining digits. There will always be one divider for your stem and leaf plots at least. Whoa, that's a really wobbly divider. Let's see if I can draw this at least a little bit straighter. Luckily that my math lab will already have this divider for you ready to go. And it's still pretty wobbly, but that one works. So the stem, the first digit, will go on the left side of this divider. And then the leaves will go on the right side. Now sometimes the My Math Lab can give you kind of an oddball question where you might see leaves on the left and right side, but whatever they have labeled as the stem, just keep in mind, no matter how cutesy or creative My Math Lab tries to be, the stem is always the first digit, the leaves are always the remaining digits for these numbers. As I'm planning this out, I see that my smallest data point is going to be 41, and my largest data point will be 99. I see that I have numbers, they're all mixed up, but I have numbers in the 40s, 50s, 60s, 70s, 80s, and 90s. So I'm going to put the stems down first so that they're ready to go here. So we have in the 40s, 50s, 60s, 70s, there we go, 80s, and 90s. And I'm just going to slash as I go just to make sure I get them all because there are a lot of exam scores here. So for example, 73 is first. So 7 is the stem, the first digit, 3 is its leaf, the remaining digits. See how easy that is? I just throw it down there in the 7 row. The 3 in the 7 row. Next up is 58. So 5 is the stem, 8 is the leaf. Done. 68. Then 75. Leave a little bit of room beside the 3. Once I'm finished with this, by the way, I'll talk about how the My Math Lab wants you to type in the leaves because it's going to be slightly different than how we would write them longhand. But let me just finish it first. So 94, so 4 is in the 9 row, 79. Just leave a little bit of space. 96, 79. Feel free to fast forward or pause this video just to see if you want to try the remaining leaves on your own, and then you can just check to see if we get the same answers here at the end. 87, 83, 89, 52, 99, 97, 89, 58, 95, 77, 75, 81, 75, 73, another 73, 62, 69, 76, 77, 71, 50, 57, 41, 98, 77. I'm running out of room here. I'm gonna have to move these over a little bit. And move some of these numbers over. There we go. There we go. There's so many numbers in the 70s, just barely gonna have enough room here. 71, 69, 90, 75, just barely enough room with my big old handwriting here. There we go. So in real life, if it were just an open-ended question, you would just leave the leaves right beside each other with just a little bit of space. In most statistics courses, your statistics teacher would not be happy if you left your final answers like this. They would want you to take this a step further and put your leaves in order from smallest to biggest. So if you're going to take statistics next semester, please be aware when you do these stem and leaf plots, please reorganize the leaves from small to big. Now the good news is that for this course, the My Math Lab does not care, yay, if they're in order. However, the My Math Lab, the way it's programmed, will want you to type in commas in between all of your leaves. So just something to be aware of. You will not ever hit spacebar, but you will type in commas in between all of these leaves. Whereas in real life, you would not write a comma in between your leaves. But that entire graph, that is your stem and leaf plot. That's section 12.1.